Yes. Yeah. Yeah. Good afternoon. All. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 8 plus years of experience in HADOOP PYSPARK environment. So yes. So as part of today's demo, right, I'll be covering the following topics. Right. What is big data? Why Hadoop? Drawbacks with the current databases, Hadoop advantages, and Hadoop and Spark job market, right? Yes. So yes, observe here. What is big data? What is big data, right? The name itself saying like huge volumes of data. Data is stored. How data is getting stored today? In KBs, in MBs, in GBs, in terabytes, petabytes, exabytes, zettabytes, sottabytes, zettabytes, right? From TB onwards, we say it as big data, huge data, right? Yes. Okay. You should have seen KBs of data, MBs of data, even GBs of data, even TBs of data. You should have seen. Do you think like petabytes of data is it getting generated in the current real world? Petabytes of data is it getting generated in the current real world? Examples of petabytes of data generation. Examples of petabytes of data generation, right? 1 petabyte equal to 1024 TBs. Can anyone please confirm whether my voice is clear? Whether the screen is
Sir,
visible?
you are totally audible.
Fine. So petabyte of data means examples to it. If you see a banking sector, right? Like a bank like SBI, within the city, we see hundreds of branches for it. Within the state, thousands of branches for SBI. Within the entire country, lakhs of branches for SBI, right? Lakhs of branches for SBI. In each branch, we see millions of customers. Again, each customer making multiple transactions per hour, per day, per week, per month, and per year, right? Each and every transaction has to be stored, right? So huge data is getting generated. Yes, huge data is getting generated, right? Yes. Apart, forget about that banking sector. For example, you are aware about the social media like Facebook, right? Facebook has got users not only within the country, throughout the world. It has got users throughout the world, right? Millions and trillions of users for Facebook. Yeah. In a minute, how many posts and videos are getting circulated? Each and every post and video has to be stored. What should be the storage capacity? What should be the storage capacity of Facebook to store all this, right? What is the data generated by Facebook in a minute? Not only Facebook. Today, if we take the example of other applications like Twitter tweets, Google queries, what is the data generated by the Google, right? Everyone are querying in the Google, and also like uploading videos in the YouTube videos upload, right? What should be the storage capacity to store all the videos? And just now I was talking about the bank transactions and Gmail Gmail messages. What should be the storage capacity for storing all the messages? Telecom transactions, e-commerce transactions, like Flipkart, Amazon transactions, right? Everywhere we see like huge data is getting generated. If you talk Google on an average generating if you talk about this Google, right? Google on an average it is generating more than 500 petabytes per month. 500 petabytes per month on an average means 500 into 1024 TBs. And if you take other applications, averagely they are generating nearly 300 to 350 petabytes per month, right? So for storing this huge data, and to process this huge data, so to currently we have got databases, right? We are storing data in MySQL, Oracle, DB2, SQL Server. They are used for OLTP, online transactional processing. We have got some specialized databases like Teradata, Netezza, Vertica. These are used for data warehouse purposes, OLAP operations. These are used for OLAP operations. Analytical processing, data warehouse purpose, right? Yes. Okay. But either these databases, specialized databases, they can handle data up to certain extent. Beyond that, they cannot. Currently, if you see the data, right? If you see the data, especially from the last 10 to 15 years, which was generated, the sources of data, what you see, right? Yes. This is your data which has got generated from the last 50 years. Assume it has generated from 1974 to 2024. If you compare that, last 10 years, 2014 to 2024 with the previous 40 years, right? Nearly 80% of the data what we see has been generated in the last 10 years, and only 20% of the data we see in the previous 40 years, right? If we see up to 2000 or 2010, right? They were CDs, DVDs to store only in GBs of data. But beyond that, now we are holding TB terabytes of data, right? So what is the reasons for huge data generation, especially from the last 10 years because of usage of technology? Technology has increased because of usage of smartphones, because of usage of internet. Today, like everyone using internet, right? Every smartphone has got internet. The usage of internet has increased. Usage of smartphones, usage of technology. And mainly we see three sources of data. Mainly we see three sources of data, right? Social data. We see like social data, machine data, and transactional data. We see like social data, machine data, and transactional data. Social data, data which got generated from the social websites like Facebook, Twitter, all this, right? Such kind of data we call like social data. Machine data, data which got generated by reading the RFID chips, scanners, all this, right? Transactional data which got generated from day-to-day operation. Transactional data, right? So here, social data, machine data, and transactional data, which got generated from social websites like Facebook, Twitter, all this we call like social data. Machine data, which has got generated from reading barcode scanners, RFID chips, such kind of data we call like machine data. Transactional data, which got generated from day-to-day transactions, like bank transactions, telecom transactions, right? Yes. And it's going to occupy mainly three types. The data which we see, right, it's going to occupy three formats or three types of data: structured, unstructured, and semi-structured. structured data, semi-structured data, and unstructured data. You can see structured data examples like DB tables, DB tables, Excel files, semi-structured data, right? Semi-structured data means like XML files, JSON files, right? Yes. Structured data like DB tables, semi-structured like XML files, JSON files, and unstructured like chart messages, articles, images, videos, all this, right? So today the biggest challenge is to handle unstructured data, right? Because today whatever data you are seeing, that today whatever data we see, right? 80% of the data which got generated is mainly going to occupy unstructured format. But databases can handle only structured data in the form of rows and columns. But they cannot handle unstructured data or semi-structured data, right? So Hadoop can handle all varieties of data, structured, semi-structured, and unstructured. So as the data is increasing enormously day by day, so we need to have some proper storage and processing systems for storing and processing the data. So to handle this huge data, unlimited data, right? We have got a framework like Hadoop. Hadoop is meant for two things. Hadoop is meant for storage. Hadoop is meant for processing. It is meant for storage. It is meant for processing. So if we talk about any technology, right? Like if you talk about C or C++ or Java, .NET, all this they are meant for processing. They are meant for processing. But if you talk about these databases, Oracle, MySQL, DB2, SQL Server, all this they are meant for storage. Means any technology if you take, they are either meant for storage or they are meant for processing. They are either meant for storage or they are meant for processing. But Hadoop is meant for both storage and processing. And for storage, does Hadoop use any databases for storing its data? No. Databases has got some drawbacks. Despite of these drawbacks, still Hadoop doesn't go with the databases for storing its data. I will just brief you about the drawbacks with the databases. Yes. So Hadoop doesn't go with databases for storing its data. Rather, it go with a kind of file system called rather it go with kind of file system called Hadoop distributed file system. Hadoop distributed file system. Yes. And for processing, we go for execution model called as MapReduce. And now we are going with Spark. MapReduce or Spark, parallel execution models. MapReduce is a parallel execution model meant for processing, and also it go for Spark. Yes. So Hadoop is meant for storage and processing. It performs both storage and processing. That too unlimited data storage and processing. For storage, HDFS, and for processing, map. So Hadoop is meant for storage and for storage, HDFS, and for processing, MapReduce, right? Now, why databases? Why databases are not able to store Hadoop's data? Yes. Drawbacks with the current databases. Observe these drawbacks with the current databases. In most of the databases, right? And also Hadoop. You may ask when Hadoop is going to perform both storage and processing. When Hadoop is able to perform both storage and processing, then what is the necessity of their current storage and processing technologies? Yes. Yeah. So you need to clearly understand. When Hadoop is able to perform both storage and processing, then what is the necessity of these technologies then? Do you think they go away from the market? You need to clearly understand Hadoop is meant for batch application. Hadoop is meant for batch processing, batch application or batch processing, right? Like for millions and trillions of records, Hadoop required. But for a single transaction or single record, Hadoop is bad for small data. Hadoop is good for huge data. So observe here, right? There are two types of applications. Hadoop is meant for batch applications. There are two types of applications, online applications and batch applications. Hadoop is not for online applications. Hadoop is for batch applications. What do you mean by online applications? User interactive application. User has to give the input. Here, user gives the input. If you want to make an online transaction, you should give the input, right? Source account, destination account, how much you need to transfer, right? Or if you want to book a movie ticket, right? The online application, right? Batch application, user non-interactive application. Here, user is nowhere required. User won't give any input here. User is nowhere required. Railway ticketing PNR status. For example, your railway ticketing PNR status is 200. After 1 hour, it became 150. Tomorrow morning, it's 100. Tomorrow evening, it got confirmed. Here, user has nothing to do, right? It happens automatically, right? So generating credit card statements for millions of customers. Here, user is nowhere required. Or even if phone bill statements generations, right, for millions of customers. So for millions and trillions of records, this Hadoop is required, right? And I was discussing what was the current drawback with the databases. One by one drawback of the databases, right? Yeah, most of the databases. Yes, drawbacks with the current databases, right? Limited storage. Most of the databases, you can see GBs or TBs of data, but unlimited data storage is not possible, only limited storage. Secondly, right, most of the databases, no parallel processing. Yes, how data processing is, yes, Arun B, right? How data processing can be done for unstructured data? We need to make the data structure and making some kind of querying on that, right? Unstructured data, we need to make it structured. Yes. Even semi-structured data, we need to make it structured and performing querying on it. And other drawbacks with the databases, most of the databases, no parallel processing in most of the databases. No parallel processing in most of the databases. Yes. And if volume increases, speed decreases. If the volume of data increases, right, the speed of that decreases, right, database. Example, select a sum of amount from sales one, has got 10 records. Select a total amount from sales 2, which has got 1 lakh records. Select a total amount from sales 3, which has got 1 crore records. Observe total amount from sales 1, total amount from sales 2, total amount from sales 3, which has got 10 records, 1 lakh records, 1 crore records. Which query is going to execute faster? Total amount of 10 records, total amount of 1 lakh, total amount of 1 crore, right? Yes. Which query is going to execute faster among this? Which query is going to execute faster among these three? Means obviously the first query, right? Of 10 records, total amount of these 10 records as compared with the total amount of this 1 lakh and 1 crore. Query to query, as the data increasing, speed decreasing here. And even if complexity increases, speed decreases. Complexity increases, speed decreases, right? total amount from sales one, average amount from sales one, standard deviation of one sales one, right? So here, query to query, if you observe, right, which query executes faster among these three? Which query executes faster among these three means, see the second one, average amount is a two-step process. First sum to be calculated, next standard deviation, first sum to be calculated, next average to be calculated, right? As compared to the first query, second query is going to take more time, and third query take a lot of internal processing. And the major drawback with the databases, they can handle only structured data. They cannot handle unstructured or semi-structured data. Databases can handle only those which are in the form of rows and columns. They can handle only structured data. They cannot handle unstructured or semi-structured. Yes. So for example, I was giving an example, right? Yes, reviews. You want to take reviews for a particular movie, right? You want to take reviews for a particular movie. User and review. You want to take review for a particular movie, like user one, user two, user three, like 100 users giving feedback. So among this 100, right? Yes. First person saying the movie is good, second saying the movie is bad, movie is good. Means one indicates movie is good, zero indicates the movie is bad. Can you write an SQL query, right, to count the number of ones and zeros? Single grouping, single aggregation, count aggregation, select review wise, review wise count I want, review wise count I want from reviews table, group by review, right? Review wise count I want from reviews, group by review means the output. Review wise means 1 or 0. Count indicates 80 people saying the movie is good, 20 people saying the movie is bad. Means if you have got in a structured format in the form of rows and columns, okay, you can perform this. Databases can perform this operation. But generally, reviews won't be given in the form of ones and zeros. They will be given in the text format. First person saying movie is good, second person saying movie is not good. So they are saying in the form of this in their own text format. Now, can you write an SQL query, right? Can SQL handle this kind of data? So you cannot say how many people saying good, how many people saying it's not good. So even SQL cannot perform this kind of, it cannot handle this. Even if you see with the keyword count good, it gives wrong computation because even not good has got good in it. It will have wrong count. Okay. So these are the drawbacks, right? Despite of these drawbacks, Hadoop doesn't go with databases for storing its data. So despite of these drawbacks, right? Yes. How can we convert it to structure? Okay. So a lot of pre-processing is required, right? So making the data keep on making it structured. We have got tables. We will be creating, we have got a concept of tables, internal and external tables. We keep on creating the tables, right? Until you get the desired output. We have got the concept of sentimental analysis, right? Yes. Now, okay. So despite of these drawbacks, major drawbacks with the databases, limited storage, no parallel processing, and they can handle only structured. They cannot handle unstructured or semi-structured, right? Yes. So that's why Hadoop is going with a kind of file system called as Hadoop distributed file system, right? And before you go with further Hadoop advantages, right? Hadoop follows master-slave architecture. It won't follow client-server architecture. If you give a request, getting response, that is not this kind of architecture. It's not like client-server when giving a request, getting the response. It is like master-slave architecture, right? So we say like Hadoop cluster, group of nodes or CPUs, they are connected in a network. The interconnected, right? Okay. One will be the master and all the remaining will be the slaves. So like a master and slave, single master and multiple slaves, right? Multiple slaves which are interconnected. So it follows master slave architecture, master slave. So if you want to handle huge data, right? Multiple slaves, multiple systems, right? All this we call it like slave nodes. We like data nodes, we say. This one master node. Within this master node, we have got a name node. So master node, name node, slave node, or data nodes. Here, why the name data nodes means data stored within the slaves. Data is processed by the slaves. In Hadoop, if you talk about a file, in Hadoop, if you talk about a file, right? Yes. The file data is stored in the form of files in Hadoop. In databases, data is stored in the form of tables. But in Hadoop, data is stored in the form of files. If we talk about this systems, right? S1 is one, S2 is one, S3, S4, 100 systems. So this entire thing, we call it like a cluster. We call this as a cluster, Hadoop cluster, group of interconnected nodes. So each system, think 1 TB, 1 TB storage, 1 TB, 1 TB, 1 TB. But the file size is 2 TB, which cannot fit into any of this system, right? So generally, like a Hadoop file will be divided into smaller parts. It will be divided into smaller parts. We call them as blocks. Later, I'll brief you about the blocks. But now, file divided into smaller part. Each part will be distributed across multiple systems, multiple slaves. Means data is divided into parts and distributed across multiple systems. And these multiple systems, slaves, what we say, right? They are going to store, they are going to process them parallelly. Parallel processing is going to happen. Two advantages you are going to see: distributed storage and parallel processing. That's why very high speed processing, a single file processed by multiple systems parallelly. That's why unlimited data storage is possible. Yes. So here this master node and slave node, right? We say about this master node and slave node. Master node response. See, data is stored by the slaves, data is processed by the slaves. Then what is the work of master node? Assigning the task T1 task to S1, T2 task to S2, T3 task to S3. Assigning who is going to assign the tasks? Master nodes. If these multiple systems are executing multiple tasks parallelly, suddenly if any one system goes down, and if any one system fails, then the task of it has to be assigned to any of the other system, right? That work is taken by master node. That we call fault tolerance mechanism. I'll be briefing you about that fault tolerance mechanism, right? When multiple tasks are executed by multiple system, if any one system goes down, the task of it will be assigned to any of the available slave. That we call fault tolerance. Master node responsibilities, assigning task assignment, load balancing, load balancing, fault tolerance, Load balancing means the task should be equally assigned to all the slaves, not burdening a particular slave. Fault tolerance. Just now I was talking, if any particular system goes down, then the task of it assigning to other slave. Health status, monitoring the health status of each and every slave node. See, Arun B, there is a query asked, what file format of data can be generated in HDFS? In HDFS, you cannot generate a file. See, LFS is there, local file system. Okay, you can create files. You've got file editors like VI editor, Nano editor, right? In LFS, local file system in Linux environment, you can generate files like using VI and Nano editors. But in HDFS, all these file editors not supported. In HDFS, you cannot modify. In HDFS, you cannot overwrite. So these file editors are not supported. You are going to pull the data from the different data sources, from different branches, from different OLTPs. You are going to pull the data into HDFS. If your organization has got 10 branches from 10 cities, you are going to pull the data into single place, HDFS. Thereafter, after the 10 branches data you take as input and perform some based on some business logic, you are going to process it. Okay, HDFS is the main area, right? Where you are going to pull all the data from different sources, where it can accommodate huge data. There, after that, we follow not ETL, ELT. We follow ETL means extracting, transforming, loading. But here, extract, load, then transform. After loading, ELT we say ELT model. Extract, load first. Extract from different data sources, load it, and apply some business logic, transform it according to it. Original data remains as it is. And after that, whatever the results you get, again, if you want, you can take it back to the data sources like databases. Slave node responsibilities, storing the data and processing data. Totally everything done by the slave nodes, right? That's why the name slave, right? They are going to store, they are going to process. Later I discuss more on this, right? In the architectural part, storage will be due. But before that, Hadoop advantages, right? Mainly unlimited data storage, right? Unlimited data storage is possible in Hadoop because there is a feature called horizontally unlimited scalability. Horizontally unlimited scalability means, for example, if if you're running a business with some slaves, some slaves you have got, some 20 systems, you're running the business with 20 systems, right? So your business has increased, your branches have increased, your customers are increased, your data has increased. Still, you cannot go with the same number of slaves, right? Yes. Customers increased by 100 times, data increased by 1,000 times. You cannot go with same number of slaves. Horizontally you keep slaves, right? Okay, that is what horizontally unlimited scalability, right? Very high speed processing is possible here because of parallel processing means your data is distributed across hundreds of systems and processed by hundreds of systems parallelly. Can handle all varieties of data, structured, unstructured, and semi-structured data. Hadoop. It's an open source. No licensing is required for this. Most of these Hadoop products are this Spark, PySpark, all this, right? Your Apache software, mirrors site. All these are the products of Apache. They are taken from Apache mirrors. You can install it. Commodity hardware means Hadoop can run on any hardware. It's not doesn't mean that on a very high configured systems, no, of any configuration, right? It can run. So there are many tests done already, right? To test the speed of different databases in the market, right? So Yahoo has performed a test It has taken a table of 100 TB consisting of 1024 columns. The task was sorting based on 16 columns. Sorting based on 16 columns. So time taken by the different databases for this task, that is sorting this 100 TB of data based on the 16 columns, right? Oracle has taken nearly 3.5 days to process it. And MySQL has taken nearly 6 days to process. Teradata, specialized database, right, used for data warehouse purpose, has just taken 4.5 hours to do that task. Netija, it has just taken 3 hours. Another specialized database for data warehouse, that's just taken 3 hours. But finally, Hadoop has just taken 3.4 minutes of time. Latest version of Hadoop has taken 1.2 minutes, right? That is what the speed of Hadoop as compared with other things, right? So Hadoop is proven in the market, storage point of view and processing point of view. Processing point of view, very high speed processing as compared with other things. Yes. So most of these projects, like ETL kinds of projects, are migrating towards Hadoop and the Spark environment, right? Where they have got and PySpark. Talk about Spark or PySpark, very high speed processing, right? Yes. Not only processing point of view, even storage point of view also, right? Even storage point of view also. Yes. If you see the storage point of view, you may get a query. Why databases like Oracle cannot support unlimited storage? So if you talk like databases also, they have got databases also can go with multiple, but there is a limit on the number of slaves. Talk about Oracle, maximum it can go with 256 nodes. Filled, they cannot store data further. MySQL also they can support up to 54 nodes, but MySQL Express can go with 256 systems. SQL Server 256, DB2 256. Teradata can go up to 512 systems, CPUs. Used for data warehouse purpose, but currently they're supporting 1000 systems, 1024 we interconnected. But once this still 1000 systems, we cannot say it because once they get filled, they cannot support data further. But there is no limit on the number of slaves that Hadoop can have, right? There is no limit on the number of slaves that Hadoop can have. Unlimited scalability. Yahoo, when first time implemented Hadoop, that went with 4000 nodes systems. Currently, it is going with 12,000 systems like Yahoo. Talk about Facebook, when first time Facebook implemented Hadoop went with 8,000 systems. Currently, it's going with 42,000 systems, Facebook, for storing its data. Yes. So as part of this course, right, Hadoop ecosystem components, right? Some Hadoop components which are not going to discuss. I'm not going to spend time on those which are outdated, right? Like there was a Apache Pig. Apache Pig, it's very much used in the industry. With very less coding, we can perform the tasks. We used to use a language called Pig Latin for that. Pig Latin language. It's a Hadoop component, right? Apache Pig. We use Pig Latin language. So very 100 lines of Java code you can write within 6 lines in Apache Pig. That is in Pig Latin. That much simple, right? But when Spark came into the market, when Spark was introduced, Spark is also a data flow. Apache Pig is also data flow. So Spark dominated. So you see, like Apache Spark, when Apache Spark introduced, that Pig is no way used. It is not used in the current market. So that is Pig or Pig Latin. Now we are not at all using it, right? Yes, even MapReduce, okay, internally each and every Hadoop component MapReduce execution is going to happen. Previously, if you go exactly 10 years back, 2012, 13, 14, 15, people who are from Java background only used to update with Hadoop because total at that time only HDFS MapReduce implementation totally using Java language where people used to write huge codings, lot of programming code, and people slowly the demand for this was good, but because of that huge codings, lot of programming required through Java, people started migrating to other technologies from Hadoop. But when later when Apache Pig was introduced, okay, we have got a language like HQL, which is SQL. We are going to make the data like in using HQL Hive query language, which is similar to easy, right? The data processing is made easy. Used even today. Apache Hive is used mostly today in most of all the applications and projects Apache Hive is used. So here with very less code, Apache Pig also used very less coding as compared to this. But when Spark was introduced, that Apache Pig is not used more. SQL plus Hadoop, the first two characters of three characters of this forms scoop, right? We used for import or export operation, importing from databases to Hadoop, exporting from Hadoop to databases. So Hadoop, this HDFS doesn't have anything from other data sources, and later by Hive or MapReduce or Spark, we'll process it. After processing the result again, if you want to export it back to that other data sources, we use this scoop component mostly used. And also like NoSQL databases. If you see the top 25 e-commerce sites, they use NoSQL database, right? Schema-less behavior. Talk about that top e-commerce sites, Flipkart, Amazon, all these. They use NoSQL database, which has got schema-less behavior. Schema-less behavior means if we talk about SQL, the database, right? From the first record to last record, same number of fields has to be maintained. But here NoSQL, record to record, different number of fields can be maintained, different number of columns can be maintained. My first record with 3 fields or 3 columns, second record with 5 fields, third record with 10 fields. Record to record, any number of fields can be maintained. That is schemaless behavior. And random access, not sequentially, randomly you can access, dynamics access we say, right? NoSQL database like HBase, Hadoop's database, it, and Yarn, yet another resource negotiator. How this processing is going to happen, Yarn architecture, Yarn components, Yarn processing, how the request is processed, the entire architecture, this components processing will be discussed in that. Zookeeper, which is controls and coordinates all these components, right? Giving connections, all this will be taken care by this Zookeeper. And I'll also provide knowledge on this Flume Kafka, that is streaming data, live streaming data, we said data which keeps on generating, the data which keeps on incrementing. Such kind of data we call like streaming data. So to capture that kind of data, we use technologies like Flume and Kafka. Kafka is which is mostly preferred, and PySpark, very high speed processing, which is mostly used, which has got great boom in today's market. So more than 50 to 60% of our time we'll be spending on this PySpark. Nearly 60% or 60 to 70% of our course time will be spent on this PySpark. Only like the 30 to 40% I'll be spending on this Hadoop, because PySpark is a technology which is mostly used in today. And even if you see that job opportunities on this PySpark and the packages for this PySpark, I've got bigger packages for PySpark. In the same way, they expect the knowledge on it, right? Like PySpark core programming, it's SQL programming, streaming, and machine learning library. Because even Python and this Spark, they have got ML. We have got many libraries for this machine learning, right? Yes. No need to perform. We have got inbuilt functions for that. Yes, observe here. Just a small introduction on this Apache Spark or PySpark. So what is Apache Spark? So generally, all these are open sources, right? There are no licensing required. It's an open source. And as I said, this is distributed systems, distributed cluster computing systems introduced by Apache Software Foundation. So I can say this Spark is for big data analysis, for processing, and for computation. In-memory computation, we say, right? Data is stored within the RAM. Data is processed by the RAM only. Generally, data stores within the disk. Here, data stores within the RAM and data processed within the RAM, both memory level. That's why we say in-memory processing, in-memory computation. That's why we see very high speed. And why PySpark? It's a Python API to use a Spark. Python API to use Spark. So I can say this is one of the fast, lightning fast technology PySpark that is designed for fast computation. It's one of the in-demand tool among the data engineers for working with bigger data sets. And Ian here using need for what is that using PySpark running distributed SQL queries, creating data pipelines. You can ingest data into these databases. We can run ML algorithms, working with the graph algorithms, with the data streams, right? Many more, right? So it provides all this advanced, it supports advanced analytics. Need for, okay. So yeah, need for PySpark, right? So if you see today, huge data is getting generated for everywhere, as I said, from YouTube, from Google, from Gmail. All the applications are generating huge data. The data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful informations, right? So we need to extract the valuable data from this raw data, right? So we require some efficient tools for performing these operations. So some flexible tools to crack this big data and gaining some benefit from this. So PySpark is such a kind of technology where we can extract the useful information from the raw data. And also, yes, so combining Python and Spark is a very efficient way for the world of big data. So Apache Spark community came up with a technology called PySpark, like Python API to use Spark. PySpark is one of the API of Python, right? And real life usage of PySpark, I said it was used in many sectors like commercial sector, right? So Apache, this PySpark used in real-time processing like banks and financial systems. They use Spark to retrieve the customer's information and analyzing that useful insights which can help in taking the right decisions, right? It also plays an important role in fraud detections and even in the healthcare. So today, like using this PySpark, we are able to analyze or identify which patient is going to face issue. And also in the entertainment industry, like Netflix using this Spark, it's popular online entertainment platform, right? For real-time processing, right? For online movies or web series. So here Netflix, it will process nearly 450 billion events per day. And for e-commerce also, right? E-commerce like Flipkart, Amazon, all this, they are using this Spark for advertising, right? People who purchase a particular product also recommending the other product, right? Such kind of recommendations. And also it offers enhanced customer experience, right? And even in the tourism industry, advising the millions of customers by comparing the hundreds of tourism websites. So if you see PySpark jobs, you can just check in the Google, right? PySpark jobs, the jobs for it, and also the salary packages for it, if you see, will be 1.5 times more than other technologies, right? In the same way, they'll be expecting the technical skills of this. So we'll be discussing each and every functionality of this PySpark. As I said, more concentration will be on this PySpark, but I'll be also providing all the knowledge about this, the other Hadoop technologies which are used is required for this, like Scoop for import export, Hive for data warehouse kind of an environment, also for integration with other different technologies. This Hive, NoSQL databases, HDFS for storage, and for streaming like Flume, Kafka, right, which are required. So this is what big data introduction, right? Big data need for Hadoop sources, types, challenges, advantages of Hadoop ecosystem components. And you need to know something about this HDFS, how the storage is happening. HDFS architecture, you need to know about name node, data node, secondary name node, job tracker, task tracker, the previous architecture and the latest architecture, and how it is divided into block, what is the default block size, and metadata management, storage and processing, replications, duplications. If any system goes down, then the data is lost, right? And how it has to be duplicated, right? If it is a sensitive data. And fault tolerance mechanism and MapReduce. MapReduce is an execution model. It is well designed, right, for parallel processing. So knowledge on this MapReduce and Scoop. A lot of discussion on Scoop and how the import and export is going to happen. And during from databases to Hadoop, you can do lot of transformations, lot of operations you can perform. While importing data from different data sources to Hadoop, I doesn't want the entire data, specific data, particular city data I want, or particular department data if you want. Means filtering can be possible while importing, merging can be possible while importing, grouping can be possible, filtering columns, filtering rows, and generating new fields can be possible while importing. And also we can perform join operations also while importing. While importing only we can perform all this. When data comes into a Hadoop HDFS, right, you can see only the specific data, not the entire data, right? Lot of operations we can perform through import, and also export operations. What are the various defining Scoop jobs, incremental loading, incremental import, working with different types of delimiters, horizontal and vertical matching. And yarn, right, it's one of the important component, how this exact processing is happening within this, the processing, different yarn architect, yarn components, resource manager, this everything you need to have the knowledge about each and every component. NoSQL database, different types of NoSQL database, and HBase one NoSQL database, how to perform CRUD operations, different creating, inserting, and all this, performing different CRUD operations, and integrations, HBase and Hive integrations. Hive, it's a data warehouse kind of. Hive is the one of the important component of Hadoop, mostly. The questions also asked from this Hive only, right? Maximum Hive and Scoop. Hive is a kind of data warehouse kind of an environment. So difference between HQL and SQL, 90% they are same, HQL and SQL, right? Means, but what HQL cannot perform is they cannot handle this semi-structured data, structure, unstructured data, right? But for example, XML kind of data or JSON kind of data, right? Even like those kind of data, like XML data, JSON data, URL data, weblog data, right? All these to process, and also creating internal tables, external tables, working with URL weblogs, inserting into local HDFS, UDF, UDAF, UDTF, non-partition table partition, multi-column partitioning, static partitioning, dynamic partitioning, performance tuning mechanism, how to increase the query performance, right? Bucketing in Hive, indexing in Hive, combination of bucketing and indexing, combination of partitioning and bucketing, combination of partitioning, bucketing, all the three together, right? For better performance. Yes. Coming to PySpark, each and every PySpark functionality we'll be discussing, right? Like PySpark, need for PySpark, PySpark RTD, parallelizing, repartitioning, broadcast, PySpark RTD computations, RTD persistence, persistence options, core computations, fault tolerance mechanism, grouping segregations, various inbuilt actions and transformations, right? So one by one, each and everything with working example, PySpark SQL. different data frame APIs, dataset API, creating data frames. Data frames mostly used today, right? Making the data structure, creating data frames in rows and columns. And what are the different functions we see, like column class, collect, select, collect with column renamed, where, filter, drop, order by, sort, join, union. We have got many inbuilt functions for all this. We'll be discussing all this, right? And SQL functions, aggregate functions, window functions, JSON functions, date and timestamp functions, and PySpark inbuilt functions when EXPR, lit split, translate, overlay, timestamp. Yes, all this, right? All these functions. And PySpark external sources, working with SQL statements, Hive integration, MySQL integration, transformations and actions, narrow and wide transformations, adding new columns, dropping columns, renaming columns, handling nulls, window function, writing data back to external sources, deployment modes, local mode, clustered mode, and PySpark application stages and tasks, narrow and wide transformations, drivers and executors, building Spark applications, pipelines, deploying Spark applications to cluster and tuning, performance tuning, PySpark streaming components, integration with Kafka, right? So this is what in brief will be discussed, right? Yes. So first Hadoop is going to be discussed here. Hadoop is going to be discussed. Hadoop components like starting with HDFS, Scoop, NoSQL, Eon, coming to this Hive. Hadoop components will be discussed, and later coming to PySpark. So here it's a so here in this course, right, PySpark, everything goes in Linux environment, and Python. So PySpark means everything the coding is done in Python. So you need to have the knowledge of Python. So it's a package, it's a total package, right? 15th K, where you will learn how to PySpark, Linux, and Python. But if you already got knowledge on Python, so here it's 12K, right? It's the fee for it if you already know. But if you are updating with Python, if you're already updating with Python already, if you have paid some amount for Python, like 5,000, excluding that you can pay the remaining, right? So Hadoop, PySpark, Linux, and Python, right? So first Hadoop is going to be discussed. Meanwhile, people will be updating with Python parallelly. Hadoop and Python, Hadoop in the weekend, and Python in the weekdays from Monday to Friday. So on Monday at 8 a.m. in the morning, and Monday and 7 p.m. in the evening, there are some batches of Python will be starting, right? So can get enrolled and just attend the sessions, right? Monday, you who wants to prefer morning or evening. So first, initially it will be at 7 p.m., right? But the batch timing will be at 9 p.m. after 1 week. First week it will be at 7 p.m. Observe this. Python timings. First week it will be at 1 week. After 1 week, it will be at 9 p.m. The original timing of this Python batch will be 9 p.m. So nearly for 1.5 months, you can attend the Python sessions, advanced core and advanced. Here also morning 8 a.m. for 1 week, it will be at 8 a.m. But after 1 week, it will be at 7 a.m., the original timing of this batch. So check with this online team. You can see that contact details of the online team, right? So attending Python parallelly, Hadoop parallelly. But if you want to, there is one more PySpark batch also going to be able to attend that PySpark also. If people can attend PySpark, just last week practicals have started for it. You will get the videos of this, which was if you want to go parallel. Otherwise, after completing Hadoop and means after doing with Hadoop and you want to go after 1 or 1.5 months, right? You want to go with PySpark, you can go with the PySpark. New batch will be started.
When this PySpark batch got started, sir?
So last week practicals was started. The before week where there was introduction, like 2 to 2 weeks I have completed, 2 to 3 weeks I have completed. basic. First week was the basic introductory session. Second week something theory on that. Last week practicals, just the introductory
Oh,
level. So if you are able to go with that PySpark, if you want to go parallel, if
I
you
know few basics of PySpark,
so
sir,
that
so I can manage.
so there will be a class at 4:15
What?
after this class immediately followed by the PySpark class 4:15 4 to 6 actually 4 to 6 p.m. every week it will be. So if you are able to attend even this week, you'll be getting the recorded whatever the videos happen, sessions happen. You can go through, and if you can attend next week or whatever it is, you can just talk with that online team. You can go through the videos. It is very simple. Every statement by statement, everything is explained in that videos, introductory sessions in that video. Yes. If you want to attend all this parallelly also, Hadoop, like afternoon it will be right, starts at 2:30 p.m. and the PySpark at 4:15 p.m. every Saturday. This will be on Saturdays and Sundays, 2 hours, Saturday and Sunday, right? 2:30 p.m. this Hadoop will start. PySpark starts 4:15, and this Linux will be covered, right? During this, before we go with the actual practical part. In this Hadoop, it will be covered. Linux, before the Hadoop practical start, Linux is going to be covered. And Python in the weekdays, like 1.5 to 2 months it takes for the Python core and advanced, right? You can attend all this Python sessions, right? Even if people are unable to attend, you'll be getting the video where you can, if you can go to the videos also, clearly it can be understandable, right? Notes also will be getting for it. So it's fine. So most concentration will be on PySpark, right? More time will be spent for this PySpark. Okay. So this, okay, all the softwares for this, everything I'll be providing, right? Where you can do the practicals of all this. Everything goes in Linux environment. Okay, fine. One second. So now just duration of the weekends, right? For total Hadoop and PySpark, for total Hadoop, if you are going one after the other, if you are going one after the other, right? Actually, 1.5 months, nearly 1.5 months for Hadoop, 1.5 months for PySpark, 3 months, right? Totally 12 weekends it will be. First, after completing of Hadoop, going with PySpark means 12 weekends it will be. 3 months it will take. But if you are going parallelly, right? Hadoop and PySpark parallel, if you are going, it will complete less than 2 months. 2 months, right? Because you'll be spending 4 hours on Saturday, 4 hours on Sunday, 2 hours on Hadoop, 2 hours on PySpark, 4 hours, 8 hours per week you will be getting, right? If you're going parallel. So that depends upon you, right? If you've got some basic knowledge, I'll go with Hadoop and PySpark parallelly. But if you doesn't have that knowledge, slowly after completing Hadoop, you can go with PySpark. Knowledge of HDFS, a little bit knowledge of Scoop is required, right? Okay. How exactly data stored and processed? See, just what is happening, how exactly data storage and processing, how exactly data is stored, how exactly data is stored in Hadoop, right? See, in Hadoop, as I said, right, in Hadoop, data is stored in the form of files. Data is stored, understand this, data is stored in the form of files. Data is stored in the form of files. In databases, data is stored in the form of tables. Each file again, each file is again divided into blocks. Each file is again divided into blocks. It means a file cannot fit into a particular system. It's again divided into smaller parts called blocks. Default block size. Actually, default block size. Previously, it was 64 MB, but from Hadoop 2 version onwards, default block size from latest version, right? It is 128 MB. 128 MB. Why it is given as 128 or 64? Because too much bigger block size or too much small block size not recommended. So that's why 128 MB or 64 MB blocks you can have. Latest version it is 128 MB. Just observe here. Okay. Observe how these files are divided into blocks, how they are distributed, how they are processed. All this happens internally, which you cannot be able to see these things, right? But based upon the block size, they get divided and they'll be stored and they'll be retrieved. For example, if you are taking a file f1.txt, this f1.txt is assume that it's some banking data. The banking data. Assume the size of this f1.txt is 200 MB. The size is 200 MB. This file should be divided into blocks, right? Into smaller parts. Whether it is 200 MB or 200 TB, it has to be divided into fixed size blocks. Default block size. Default block size. Default block size, assume 64 MB into means default block size means the file has to be divided into what size blocks? 64 MB blocks. Default block size 64 MB. Into how many blocks, number of blocks, into how many blocks the file is divided, into how many blocks the file is divided means 200 by 64. 200 by 64 means how many blocks? 64, 64, 64, 4 blocks. 4 blocks means B1 block, B2 block, B3 block, B4 block. Stored in slave 1, stored in slave to system 2, stored in system 3, stored in system 4. In 4 systems, 4 blocks are distributed, stored. This one 64 MB. This is also 64. This is also 64, means 192. This one has got only 8 MB. 8 MB. Remaining everything is free. Only 8 MB it is stored. Remaining it's free. Now, f2.txt, there is one more file. f2.txt, one more file. It is this file is related to telecom, like 192 MB. The size of this is 192 MB. Default block size is 64 MB only. Assume default block size is kept as 64 MB. Means into how many, what is the fixed? It has to be divided into how many blocks. Each block size is 64 MB. Into how many blocks it is divided? Number of blocks. Number of blocks means 192 by 64. Exactly 3 blocks, right? Exactly 3 blocks means 1, 2, 3 blocks. B5, B6, B7. This one 64, this one 64, this one is 64. This is stored in S5, S6, S7. Here the query is, why this B5 data is not stored in this B4 when 56 MB is free? When 56 MB is free. Observe carefully here. If you want, if you're retrieving f1.txt, if I want to retrieve f1.txt, right? We need to combine b1 plus b2 plus b3 plus b4. If b5 data stored in b4, assume if b5 data stored in b4, +64 plus 64 plus 8 plus 56 of this b5 means totally 256 MB you will get. But actual file size of F1 is 200. But actual file size is 200, which is a wrong computation, right? Which is a wrong computation. 56 MB of telecom data also you got along with the banking data. So every file should have its own blocks. In the particular block, no two files data like banking and telecom data cannot be stored in this B4. Let it be free. All the blocks will have equal volume except the last block, right? Only the last block. All the blocks have got equal volume except the last block. And every file should have its own blocks. In a single block, no two files data to be stored. Now try to answer design principles with respect to HDFS block. Design principles you need to follow. Design principles with respect to HDFS blocks. What are the principles you need to follow with respect to HDFS block? Every file should have, yes, I want sessions to be more interactive, right? Everyone, whether your answers are correct or wrong, keep responding, keep asking queries. Live interactive sessions, right? So I was just saying, right? Every file should have dedicated number of blocks. They should have dedicated number of blocks. Means every file should have its own blocks. In a single block, what is that? In a single block, no two files data to be stored. No two files data to be stored. In a single block, no two files data to be stored. All blocks have equal volume. All blocks will have equal volume. Except the last block. All blocks will have equal volume except the last block. Okay, understood these things, right? Yes. Data storage and processing. So how the data storage and processing is happening, right, within the Hadoop. So, okay. I'm going to discuss 3 cases here. I will be discussing 3 cases here to make you understand much better this data storage and processing. Observe. Observe this case 1. Yes, case 1, right? The file divided into blocks. The number of blocks, if the number of blocks is equal to the number of slaves, number of systems, then full parallelism. Full parallelism, very high speed you are going to achieve, right? For example, number of blocks are 4. Number of blocks equal to 3. Number of slaves are 3. Now, you got f1.txt, a file I'm taking for example purpose. I'm taking a file, whatever size it is. The size of this file is 192 MB. Default block size. Default block size means into fixed 64 MB. Into how many blocks it is divided. Number of blocks. We'll only specify the default block size. Based on that, the file divides into blocks and they get distributed, right? That everything happens automatically. Number of blocks, how many? 192 by 64. 3 blocks. 3 blocks means B1, B2, B3. B1, B2, and B3. B1 has got some 10 lakh records. B2 has got some 10 lakh records. How this is going to get distributed across this master and slave? Single master, I said there are 3 slaves available. 3 slaves, S1, S2, and S3. S1, S2, and S3. System 1, system or slave 1, slave 2, and slave 3. This we call it like this master node, name node, which has got name node, which stores metadata information. Name node always stores the metadata. The metadata means data about data. It won't store the actual data. Data about data it means. Master node. Here we got a file f1.txt divided into how many blocks? B1, B2, and B3. Where B1 in S1, where B2 in S2, B3 in S3. So B1 here, B2 here, B3 here. So B1, it has got 10 lakh, assume it has got 10 lakh, has got a 10 lakh. Now, how exactly the data storage happens, right? And how the data processing, right? Your job is to process f1.txt. Job always divided into tasks. Job is divided into tasks. Number of tasks always depends on, in Hadoop, always the number of tasks, number of unique blocks, How many unique blocks here? 3 blocks. Means how many tasks? 3 tasks. T1, T2, and T3. Job is to process f1.txt. Job is to process f1.txt, right? Divided into T1, T2, T3. T1 task is for executing. For executing what? The B1 10 lakh records. T2 task for executing B2 10 lakh records. T3 is for executing B3 10 lakh records. Who should execute this T1 task? T1 task should be executed by whom? Which system, which slave has to execute it? As T1 task is to process B1 block, right? The B1 is present in the system 1. System 1 only can execute, right? This B1 10 lakh records. System 2 can't execute it. Try to respond for this. Who has to execute this T2 task? Which system? T2 is for executing B2, right? B2 10 lakh records. System 2 only can execute. T3 is for executing. T3 is T3 task, the 10 lakh records by S3. T1 by S1, T2 by S2, T3 by S3. So here 3 tasks, T1, T2, T3 are executed by three slaves are executed by three slaves, S1, S2, S3 parallelly. No task is in the waiting state. None of the task is in the waiting state. All these three tasks are executed by the three slaves, S1, S2, S3 parallelly. No task is in the waiting state. Okay. So full parallelism, very high speed you are going to see when the number of blocks equal to number of slaves. Okay. Next, case 2, observe this case 2. In the case 2, number of blocks are more than number of slaves. Number of systems are less. Assume 4 blocks, 2 slaves. Here B1, B2, B3, B4. Slaves S1 and S2 only. Number of blocks are more, number of slaves are less. Then in such case, less speed, you cannot achieve high speed. Less speed. Yes. Take a 5. I have taken a file of 230 MB, default block size 64 MB, number of blocks 230 by 64, 4 blocks. B1, B2, B3, B4. How these 4 blocks are stored across this cluster, which has got only 2 systems, S1 and S2. Here B1 here, B2 here, B3 here, B4 here. And this is name node, master node, name node, stores metadata information, f1.txt divided into 4 blocks, B1, B2, B3, and B4, where B1 stored in S1, B2 in S2, B3 in S1, B4 in S2, right? 4 blocks stored in only in 2 systems. They are distributed across 2 systems. This is how the storage is happening, right? This is how the storage happens. Then data processing, right? Data processing. Data processing, okay. Always the job is to process the file f1.txt. Always the job is divided into tasks. In Hadoop, always the number of tasks equal to number of unique blocks. Number of unique blocks. How many blocks? Here, 4 blocks. 4 blocks means how many tasks? 4 tasks. T1, T2, T3, T4. Job is to process f1.txt divided into 4 tasks, T1, T2, T3, and T4. T1 is for executing. T1 task is for executing B1. T2 is for executing B2. T3 is for executing B3. T4 is executing B4. who should execute this T1 task? System 1. T2 task means for executing this V2, S2 can do it. T3 task for executing this B3 present in S7. So S1 only can execute. T4 task again executes by S2. If you observe carefully, S1 and S2. S1 executing T1 and T3 task. S2 executing T2 and T4. So here when T1 is executing in system 1, T3 will be in the waiting state. In S2, when T2 is executing, T4 will be in the waiting state. Means when these two are executing, the other will be in the waiting state. Once this T1, T2 execution finished, then only T3, T4 will start their execution. Means here some tasks are in the waiting state. So that's why less is speed here. 1 second. So yes, you'll be getting the clear notes of it, not a worry. So all these clear notes I'll be providing for all these cases. Okay. Next, observe this case 3, right? Observe this case 3. More blocks, only one slave. No parallel processing at all. No parallel processing. B1, B2, B3, B4. Only one slave S1. Assume this is your master, this is your slave S1. In this S1 only B1 stored, in this B2 is stored, B3 is stored, B4 stored. Means your F1.txt divided into 4 blocks, B1, B2, B3, B4. B2 also in S1, B3 also in S1, B4 also in S1. So if you are processing, go to this processing, right? Job is to process F1.txt. F1.txt. Always if the job divided into tasks, then only parallel processing can be achieved. Number of tasks always depends on number of blocks. Number of blocks, how many? 4 blocks, means 4 tasks. T1, T2, T3, T4. Who should execute T1? S1 only. T2, S1 only. T3, S1 only. T4, S1 only. All these 4 tasks are executed by single slave, sequentially one after the other. Assume a task takes 1 hour time. One task takes 1 hour time. In the case 1, 3 tasks, 3 slaves. 3 tasks, 3 slaves. What is the total time taken to execute all the 3 tasks? What is the total? 3 tasks are executed by 3 systems or 3 slaves parallelly. Total time taken 1 hour only, right? Or you take 4 tasks, 4 slaves, 1 hour time it takes. Because all these 4 tasks are executed by 4 systems parallelly, 1 hour can complete. Case 2, 4 tasks, 2 slaves. What is the time taken? First, the 2 slaves executes the 2 tasks first, 1 hour time completed. Next, in the T3 and T4 again they're executed by these 2 slaves. 2 hours time it takes. In case 3, 4 tasks, only 1 system, 1 slave. Means 4 hours it takes, one after the other. Right? So in this case, if I go back to this case 1, right? Case 1 you observe, right? T1 task assigned to S1, T2 task assigned to S2, T3 task assigned to S3. 3 tasks are assigned to the 3 systems, 3 slaves. Three tasks are assigned by the 3 systems. Suddenly, 3 tasks are executed by suddenly if any system goes down, it's not working. Then 10 lakh records are lost. If it is a sensitive data like banking data, huge loss, right? Then here you see 2 drawbacks. The data is lost and T2 task is failed. And how Hadoop is able to overcome this kind of situation, right? So we have got a concept called replication and fault tolerance. We have got the concept of replication and fault tolerance. Replication and fault tolerance, yes. What is replication and fault tolerance? We'll just, I'll brief it in the tomorrow session. How Hadoop is going to overcome those kind of situation, right? Data loss and task failure. And tomorrow I'll be discussing the architecture, right? Hadoop architecture. So tomorrow also, right, you can attend the session. So tomorrow we'll start the session, right? 2 p.m. We'll start the class at 2 p.m. You can follow the same today's link only. More discussion on this, right? Right, 2 to 4. Tomorrow we'll be having the class from 2 to 4. Right. More discussion on this fault tolerance and replications mechanism, right? 1 second, hold on. What the notes up to here I'll be forwarding you now. 1 second, hold on. Just give me a second. Right.